Hey everyone! Today we're starting a brand new unit and we're going to do quadratics. Sounds like a complicated word, but stick with me because I think we can get it if we work together. So I'm going to start with an introduction and kind of introduce you to some quadratics. You'll notice that the table here shows a soccer ball's height above the ground over time after it was kicked in the air. So what we're going to do first is we're going to graph the data and then we're going to draw a smooth curve through the points. So let's take a look. Now our time goes to 3 seconds and it's 0.5 intervals. So I'm going to put them on evenly spaced. Along the bottom. So time is on the bottom. And in this case, it's in seconds. Then we're going to do the height along the side. And it goes up to approximately 14. So I'm going to do 3, 4, 5. 14 ticks. Try to keep them even. I know it's much easier on graph paper, but this is how we're going to do this one. And then we're going to start graphing it. So at 0, it's at 0.1. I'm just going to use a different color to kind of put the points on. So it's down at the bottom here. At half a second, it's at 7.8. 3, 4, 5, 6, 7. So it's close to this 8. That's 8, 10, 12, 14. At 1 second, it's a 12. 1.5 is 13.8. So it's almost here at that 14. 2 seconds is at 13. 2.5. 9.75, so just under the 10. And at 3 seconds, it's at 4. 2, 3, 4. So about here. Now it says to draw a smooth curve through the points. So if we draw a curve through the points, I'm going to try to actually make that a little bit smoother. Just gonna put that point here. So notice that it makes this curve where it goes up and then comes back down. Okay, so describe the shape of the curve. So you can say that there it goes up and comes back down. What was the ball's maximum height? So you can look on here, and the maximum height, you can look on the graph or on the table. Maximum height was about 13.8 meters. So that's C. And for how many seconds was the ball in the air? So you can look at it from the graph, like when did it hit the ground? And it hit it just after 3 seconds. So you can say approximately 3 seconds. So easy, we can answer a couple questions when it comes to this, but I want to get more into the shape of it and what it looks like, and we're going to explore these curves in more detail and look at lots of different applications to the real world. Moving down to the bottom of the page, I just want to go over a couple of the terminology stuff in terms of our quadratic formulas. Now, this type of graph is a quadratic. It goes up and then comes back down. But you can also call it, has a name. They call it a parabola. So you might hear parabola or you'll hear quadratic. They both kind of refer to the same thing. A couple of the terms that we're going to make reference to. The first one is the vertex. Now the vertex is your maximum or minimum point of the actual parabola, and it occurs right here at this point. Okay, that's known as our vertex. We have a y-intercept, and that is the point where the graph crosses the y-axis, and it is right here. We also have x-intercepts. So one is right here because it crosses right there, but it also crosses here, and we're going to explore that further in a later lesson. So in this particular example, we have two x-intercepts. That's where they cross the x-axis. And then right down the middle, the line that goes down the middle through the vertex, and it's actually halfway between our x-intercepts, smack dab in the middle, is called our axis of symmetry. So it's kind of the point where you can take that parabola and fold it in half, and you have exactly the same on both sides. Okay, it's like placing a mirror on it. So it's the very middle. It goes through the vertex, and it's the midpoint of those two x-intercepts. That's going to come in handy later. So I just want you to keep that in mind. So last thing I want to make note of is, yes, you can figure out whether it's a parabola or a quadratic just based on that shape. It's going to have that parabola shape. Either looks like a hill or looks like a smiley face. But we can also tell just by looking at the table. So what I'm going to do is I'm going to show you the first and second differences, and we're going to talk about whether it's a linear or quadratic. So in this example, what you're going to do is you're going to, our first differences, we're going to subtract this x or this y value from this y value. So it looks like this. So we take the one value and subtract the one before it. So 5 minus 0, the difference is 5. Then we're going to do it again. 8 minus 5. And we'll keep going. 9 minus 8. 8 minus 9. 5 minus 8. And 0 minus 5. Now notice that these are all different. And since the first differences are not the same, this means that it is not linear. Okay, if all the first differences were the same, then we would have a straight line and we could say that it was a linear function. Since this is not a linear function, we're going to actually look at it and see if it is a quadratic. So what you're going to do is actually take the differences of our first differences. So we're going to subtract these ones. So in this case, 3 minus 5 is negative 2. 1 minus 3, negative 2. Negative 1 minus 1, negative 2. We just keep going. Negative 3 minus negative 1 is negative 2, and negative 5 minus negative 3 is negative 2. So we notice that all of these are negative 2, and because they are all the same, for the second differences, it means that we have a quadratic. So that's how you can tell just by looking at the table. You just have to do a couple subtraction things. And then I showed you what it looks like if we have an actual graph of it. So the key ideas for this is the graph of a quadratic relation is a parabola. That's the shape of it. For any quadratic relation, the second differences are constant or the same. This word means the same. And every quadratic relation has an x squared term, or the degree of the polynomial is 2. So the highest exponent you'll see is actually x squared. So it'll have that 2 there. Okay, do some of the practice with the practice worksheet and kind of get to know a couple different quadratics and the different shapes of them. And we'll get more into it for the next lesson. Bye, guys.